Healthy Child also takes advantage of a number of visualization tools which are not so common. Tree maps along with neighborhood graphs and heat maps make up a stable of novel visualization tools that Healthy Child has made available to the clinicians and researchers through 3 applications. One is the case Revisioner, which we will look at in more detail shortly. The other 2 applications are the Semantic Revisioner and the Visual Patient Browser applications. The combination of the Visual Patient Browser and tree maps employs the full range of the feature set of Healthy Child's toolkit. We shall therefore use this combination to demonstrate some of the functionalities of Healthy Child's data visualization tools. The tree map concept allows for a space-filling representation of a data set where the records are each represented by a rectangle filling the space. This approach was utilized to give clinicians a more intuitive and powerful way to visualize the data, to present the patient information in a browser interface that is intuitive, that is customizable, and that the clinicians can play with and present hierarchies and navigate them with the goal of doing data mining. To add semantics, clinicians have made a large number of medical ontologies available, which have been derived from annotating and validating the images that we're collecting during the Healthy Child clinical studies. Expliciting semantics provides many benefits for medical applications in the fields of information integration, classification, browsing, and reasoning. The Case Revisioner is an advanced tool developed by Siemens for Healthy Child. The basic philosophy behind the design of Case Revisioner is to provide clinicians with a flexible and interactive tool to enable operations such as data filtering and similarity search over the 4 clinical centers, to provide similarity search-based decision support, and also to facilitate the exploration of the resulting sets of clinical records. The aim is to let clinicians explore and compare the patient's records regardless of their geographical location, and to visualize their place in the distribution within the whole population of patients.
This is the basic idea. So we have some validated cases in our database. We have a new case. We look up which cases are similar, and then we look at the outcome of these similar cases. Okay, so what are the advantages? This clearly is a method that relies heavily that we do have this grid, that we have a lot of validated high-quality data at leading centers. It is very generic. The idea just compare 2 patient records is very generic. So actually we have done this with genetic data, we have done this with imaging data, compared imaging data, similar images, and also with clinical data. All you need basically is you have to define what is similar, what is your distance between 2 patients. And here we offer 2 possibilities. Either the clinician tells us, okay, for me ejection fraction is the most important thing, show me similar patients with regards to ejection fraction. Or we can say, no, the system can learn something. So if we have validated data, we just give the validated data to the system, and the system does the clustering, the classification for us.
The juvenile idiopathic arthritis study covered 3 main areas. The first goal was to improve current classification of juvenile idiopathic arthritis subtypes, identifying homogeneous groups of clinical features, finding early predictors of poor outcome, and identifying sensitive markers of joint damage progression.
The first one was rheumatology, a disease called juvenile idiopathic arthritis. And in this disease, the clinicians, they are dealing with the problem that that the children with arthritis, they have to take quite serious drugs. And it's very hard to predict which patients are going to get better. The drugs have side effects, so you do not give them easily. Sometimes the disease progresses very aggressively. They do not know exactly when and why. This was the question they asked us. Can you find us some prognostic markers? Can you tell us why one child is developing this disease very aggressively, while the other one obviously has a much milder course of the disease. And in this case, the clinicians rely very heavily on imaging. Traditionally, this has been X-ray. In X-ray, the problem is you only see the damage to the bones once it's done. And there has been great interest on the clinical side to also look in ultrasound and MRI images, with the hope that here you can see inflammation, that you can get kind of predictive, that you see the disease and not only the damage done. And so the clinicians have been focused, and this will be presented this afternoon, on developing new scores based on these new imaging